Jai Hind to all. Today we will discuss the third lecture of context-free grammar. Basically, today we will discuss about the removal of the ambiguity. After that, inherent ambiguity. After that, we will go for the simplification of the grammars. Simplification of the grammars will comprise of the elimination of the useless symbols. After that, elimination of the epsilon productions, and after that, elimination of the unit productions from the grammar. Now, we will move towards the removal of ambiguity. Basically, till now, there is no algorithm available that can straightforward remove the ambiguity from the ambiguous grammar. But if you will think about the precedence and associativity in the expression grammar, so you can easily eliminate the ambiguity, means you can easily construct a grammar that is unambiguous, that will generate the string of that particular grammar's language, right? So, here you can see there is no standard solution for all type of ambiguous grammars, right? Only expression grammar can be solved or make unambiguous, right? So, the expression grammar can be made unambiguous on the basis of precedence as well as associativity, right? If you will think of this particular grammar, expression tends to expression plus expression, expression multiplied by expression oblique ID. So, if you will think, you can sort, in short, you can write down E plus E, E multiply E oblique ID. This is a grammar. Earlier we have seen this is a ambiguous grammar because for the string ID plus ID multiplied by ID, we have generated two parse tree, right? So, if you will take care of the precedence, you can simply remove precedence as well as associativity. You can simply remove the ambiguity from this particular grammar. So, to write the equivalence grammar, we can think of how can we remove the ambiguity from the grammars, right? So, to take care of the precedence, rewrite the grammar by defining the rules starting with the lowest precedence to the higher precedence. Meaning is that if this particular grammar E tends to E plus E, E multiply E oblique ID, you can start from the lowest precedence symbols and redefine the grammar's rule. So, you will write in this manner, E tends to E plus E, right? After that, redefine means you can simply T tends to according to the, this is a lower precedence, this is a higher precedence. Means redefine the rules from the lower precedence to higher precedence. Lower precedence, lowest precedence will always be starting symbol, right? You have to memorize. After that, you will think about the associativity. Inculcate the associativity. If the operator is left associative, then make the productions left recursive. If the operator is right associative, then you have to make the productions corresponding to that particular newly grammar right associative. So, you will think about this. This particular plus operator is the left associative. So, what you have to do? You have to convert it into the left recursive. So, how can you convert it into the left recursive? You will simply write down E tends to E plus, because this is left recursive, right? Change this symbol. You will write down T. You will always take the non-terminal here. If you want to make it left recursive, then you have to take this particular non-terminal from the next higher level of precedence. From the next higher level of precedence, right? After that, you will think this star is also left associative. Sorry, this is T, it is left associative. So, what you have to do? You have to make it left recursive. So, left recursive, it will be replaced by F. And there is no operator, so you have to write down simply. So, this is a grammar after associativity, right? After that, you will move, you will require a laddering, because you will never move from the starting symbol to the particular productions. Every definition is unique in itself. No operator is associated with others. So you will simply do the laddering with the next label priority, next label of production rules, right? So you will simply write down in this manner. So this is a resultant grammar which is unambiguous, right? I will see you later on. In short, I have written this particular algorithm. You can see it is a direct method to solve it. Basically, add n new terminals where n is the precedence label in the grammar. If you will think about this particular grammar, E tends to E plus E oblique E multiply E oblique F, right? So what you have to do, how many precedence? First one is the plus, after then multiply, lower to higher, right? So two precedence label will be here. So how many symbols you have to add? You have to add two symbols, two new non-terminals, not terminals, new non-terminals here, right? So I will think of T and F will be two non-terminals, right? What you have to do now? Define least precedence operator for start symbol. So what is the least precedence operator here? Plus is a least precedence operator. So what you have to do? You have to define it with start symbol. So you have to write down E tends to E plus E, right? Now what you have to do? For each non-terminals, rules are defined using operator in the next level of precedence. So next level of precedence is multiplication. So next you will select the non-terminal from here, which you have taken. So I have written T tends to T multiply F, and after that F tends to ID, right? What is the meaning? You can once again think of. For each non-terminal, rules are defined using the operators in the next level of precedence, right? So I have written next level of precedence, basically this one, E tends to E plus E, E multiply E oblique ID. So this is a next level. So from the selected non-terminals, I have write down here this one, and from the selected one, this one, I have written this one, right? So at the end of the definition, in the given, without precedence are added without to the remaining non-new terminals. Now you will think of to include the basically associativity. If associativity from left to right of the particular operators, then make the definitions left recursive, right? Simply you can see that E tends to E plus E, T tends to T star T, F tends to ID. If you will think this plus is a left associative or not, if this is a left associative, then make it left recursive. What is the left recursive? A tends to A alpha oblique beta. Means productions of the form A tends to A alpha oblique beta. You can see the left hand side non-terminal will appear at the right, extremely left on the right hand side of the production. Then you can say it is left recursive, right? So similarly, you can see E tends to E. So this must be appear extremely right, extremely left to the right hand side. Now you will replace this E by the next label T, right? Yeah, you have to memorize it. Similarly, this is the left recursive, so this must be preserved and this gets changed by the next level of precedence. So next level of precedence is F, written in form of the F production, right? So you will add F, right? So in this manner, you can go through. Since the start symbol and other non-terminals defined only the particular operators, a link is to be created between all the definitions. This is done by the adding new definition for each non-terminal as non-terminal defining operator at the next higher level of precedence. So you will link these definitions by assigning a new definition with the new non-terminal at that higher level of precedence. So higher level of precedence will be T, right? So you will append T here. Similarly, you can see higher level precedence is F. So you have to replace it by F and ID. So corresponding grammar will be E tends to E plus T oblique T. T tends to T multiply F oblique F, and F tends to ID, right? So this is ultimately unambiguous grammar. How can it be unambiguous? If you want to generate the string ID plus ID multiplied by ID, what you have to do? You will firstly use this one. So there is no possibility. You can see previously there is a two possibility. Either you can derive E derives E plus E, or E derives E multiply E, right? So there is a possibility of two parse tree by due to this one. But here you can see you will start from the starting symbol. There is a unique choice plus. After that you will move towards the multiplication, right? So in this manner you can see the possibility of this particular parse tree get eliminated, right? Now we will move towards the inherent ambiguity. So basically a CFL, context free language. Basically this is a property of the context free language, not a grammar. Context free language. Right? So a CFL, context free language, is said to be inherently ambiguous if it is defined with only ambiguous grammar. In short, we can say if there is no unambiguous grammar possible to define a context free language, then it is called inherently ambiguous. Then it is called inherently ambiguous, right or not right? If there is no possibility, you cannot write down the unambiguous grammar for that, because inherently ambiguous context free language is not suitable for the programming language, right? So so it cannot be defined with the unambiguous grammar, right? You can say, consider the particular language. L tends to A power I, B ki power J, C ki power K, D ki power L, where I is equals to J and K is equals to L. Meaning is that these are the sames, right? This particular language can be defined by this particular grammar. S tends to AB, right? What is the possibility of AB? That must be same, right? I is equals to J. So you can say you will start from the starting symbol. S tends to AB, right? S tends to AB. Now A will be what? A will be A, B. A and B will be same. And AB, terminate with AB, right? Similarly, B will be, what is the value of B? The value of B will be this one. For this one, you will write down the production. So C, after that B, D, oblique CD, right? What happens for the value if these are not equivalent? Means the value will be get differentiate. So you can see A, C, after that D. So this possibility may be also there. So what is the possibility? A and C, D, right? And AD, this possibility, right? Second one, B and C possibility will also be there. So we will think of that, right? So we can write down, add the another production. C tends to ACD oblique ADD. After that D tends to BDC. After that BC. So this is a unique production, right? Now you will think of string A, B, C, D. What happens? This can be generated by this option. You can see this can be generated by this option. You will start from S, A, B, right? This will generate A, B, right? B will generate C, D, right? You can generate it by this option, first one. You can also generate it by the another option, S tends to C, right? And C will generate A, C, D. After that, you will write down C will be, A, D, D. A, D, D. After that, you will take D production, B, C. So it is B and C. You can see A, B, C, D get generated by this. This is a 2-parse tree corresponding to this particular string A, B, C, D. So you can summarize it that this grammar is ambiguous, and there is no other grammar possible for that to depict this particular language. So this particular language is inherently ambiguous. You will move to another example. Let's a grammar is given here. L is equals to A ki power I, B ki power J, C ki power K, where I is equals to J or J is equals to K, right? Same thing will be written here. I have written this particular grammar in this form, right? AI, BI. If I is equals to J, then you can write down AI, BI, and CK will be different. Same for this one. If J is equals to K, then I have written in this manner. Now you can see the grammar corresponding to that is this one. For this one, the grammar is generated by the S1 part. For this one, the grammar is generated by this one part, right? What happens when you will get a string that will contain, suppose A ki power I, B ki power I, C ki power I. What happens means, if you will think about the A ki power 2, B ki power 2, C ki power 2, suppose this is a string. What happens? This string can be generated by this one grammar or not? Yes, this can be generated by this one. You can see S drives S1. After that, you can drive what? X and C. X will drives A, X, B. After that, A, X, B, and X drives epsilon. This C get drives what? C and C, C and C, capital C, and after that epsilon. So this get derived by this portion, right? This can also be derived by this portion. You can see. So S drives S2. After that, A by, right? After that, A by will be written in which form? A, and this A get eliminated by epsilon. After that, for by, you can see, you can use B by C. After that, B by C. After that, it will get eliminated by epsilon. So you can see yield points of this one. It is A ki power 2, B ki power 2, and C ki power 2. Same is here. A ki power 2, B. So there is a more than one parse tree, and there is no other way to write down this the grammar for this particular language. So for the common strings, if there is a two options available, then of course grammar is always ambiguous, right? You can think of that. Suppose I have written A ki power M, B ki power M, C ki power P, where M, N, and P is greater than equals to 1, right? And I have written union A ki power Q, after that B ki power N and C ki power N, where Q, N, n is greater than equals to 0, 1, sorry, where it is greater than 1. So you can think of here m and p will be same, greater than 1. You can think of the common string between both will be possible or not? Any one of you? Basically, the common string, suppose I have taken a power I, b ki power I, c power I, right? And similarly, the same common string will be taken from here, a power I, b ki power I, and c ki power I. So this language can be derived by the different grammar. This language can be derived by the different grammar, right? And at last, we will append it by the S1 oblique S2, right? Append it by S1 S2 because union will be there. String either generated in this manner or in this manner, right? Here A, B are same, C may be different. Here B, C are same and A may be different. But for the common strings, suppose A, B, C, if you will think A, B, C belongs here also or here also, then there is more than one possibility. So this grammar, the grammar corresponding to that is always ambiguous, right or not right? Because commonality will be always be there, right? So you can summarize it. The language is always inherently ambiguous, right? So because we will never generate the unambiguous grammar for it, because common strings always makes the grammar ambiguous. Due to that, the language will always be inherently ambiguous, right? Thank you very much.